So by monotone convergence theorem, when secant Sn converges, it is bounded. So secant Sn convergent if and only if it is bounded. Secant Sn convergent means partial sum convergence means its corresponding series converges, that is sigma xn convergent if and only if it is bounded. Okay. By monotone convergence theorem, secant Sn convergent if and only if it is bounded. Therefore, sigma xn convergent implies by it is bounded. Okay. Moreover, what is secant Sn? It's an increasing sequence. When Sn is an increasing sequence, so what is limit Sn? Limit Sn is supremum of Sn where n fallen n. Okay. Since Sn is an increasing sequence, come to the further argument. Let Sn be an increasing sequence. We know that Sn is an increasing sequence. Since Sn is an increasing sequence, what is its limit? Limit is supremum of that sequence. Supremum of Sn for all n fallen n. Supremum of Sn for all n fallen n. So, limit Sn equals supremum of Sn for all n fallen n. Therefore, limit sigma xn converges to where limit Sn. Sn be the nth partial sum of sigma xn. Sigma xn converges, limit Sn converges to the same limit. So, limit Sn is nothing but supremum of Sn for all n fallen n. But therefore, sigma xn converges to limit Sn means sigma xn converges to where supremum of Sn for all n fallen n. So this is the another result. If sigma xn converges, then its limiting point is it converges to supremum of its nth partials. Sn be the nth partial sum of sigma xn, and here we see that sigma xn converges to supremum of Sn for all n fallen n. Enough. Okay. Now, to prove the geometric series sigma r power n. The geometric series sigma r power n converges if 0 less than modulus of r less than 1 and diverges if r greater than or equals 1. Sigma r power n converges if modulus of r lies in between 0 and 1 and diverges if r greater than or equals 1. Or modulus of r if mod r greater than or equals 1. Great. How? So far, let Sn be the nth partial sum of the given series. Sn be the secant Sn be the nth partial sum of the given series sigma r power. So what is Sn? Sn equals 1 plus r square plus etc. plus r power n minus 1. Sum of the first n terms. What is S1? R power S1. So it is 1 plus r square plus etc. plus r power n minus 1. Okay. Sigma n ranges from 0 to infinity. Sure? So what is r into Sn? R into Sn equals r plus r square plus etc. plus r power n minus 1 plus r power n. Sure? Okay. So then 1 minus 2 or 2 minus 1 means or 1 minus 2. Sn minus r into Sn equals, like terms with opposite signs are cancelling each other, what remains there? 1 minus r power n. So that means r minus 1 into Sn equals 1 minus r power n. So what is Sn? That means Sn equals 1 minus r power n by r not r minus 1, just 1 minus r. 1 minus r. Okay. That equals 1 by 1 minus r minus r power n by 1 minus r. Taking limit. So what is limit? On both sides, limit Sn equals limit of 1 by 1 minus r minus limit of r power n by 1 minus r. What is r? Since r lies in between 0 and 1, limit r power n is always 0. So this term tends to 0. What remains here? So it is limit of Sn equals limit 1 by 1 minus r means 1 by 1 minus r. So Sn converges. Sn converges. Therefore, Sn means the nth partial sum of sigma r power n. Thus sigma r power n converges. Agreed. So sigma r power n converges when r lies in between 0 and 1. Suppose r equals 1. What happens? R equals 1 means, what is Sn? When r equals 1, come to the next case. For the divergency, when r equals 1. R equals 1, what is Sn? 1 plus 1 plus 1 plus etc. How many times? N times. 1 plus 1 plus 1 plus. When r equals 1, it is 1 plus etc. plus 1. How many times? It is n times. Means Sn equals n. Secant n is Sn equals n. So what is limit Sn? Means limit Sn equals limit n. So limit n tends to infinity, limit n is infinity. Means it is unbounded. Means it is, it is converted, not unbounded. Limit Sn equals infinity. Hence sigma r power n diverges when r equals 1. When r greater than 1, what happens? What is Sn? Sn equals 1 plus r square plus etc. plus r power n minus 1. Okay, r power n minus 1. That means, so what is secant Sn? So this Sn tends to, when r greater than 1, so larger quantity. So Sn converges to, Sn tends to infinity, means it is diverges. So sigma r power n diverges when r mod r equals 1 or greater than 1. It converges when it lies in between 0 and 1. Agreed? Okay, thank you.